Hello and welcome students. We are solving problems on derivative of implicit functions. In last lecture, we had done this question. Now similar type we have few more. The next one is e raised to x plus y equals to cos of x minus y. This problem you all can try on your own. E raised to x plus y equals to cos of x minus y. What you will do, you will differentiate both sides and then you will get dy by dx on the left hand side as well as on the right hand side. You will get dy by dx on the left hand side as well as on the right hand side because of this y here and this y here. What you will do is those two dy by dx you will try getting on one side, get dy by dx common and then shift the factor in order to get the dy by dx. You have to write the answer subject to dy by dx. The next one you have is cos of xy equals to x plus y. Now this is also very easy question. You will differentiate both sides with respect to x. Why with respect to x? Because you have to get dy by dx. So derivative of this, see this also you can solve on your own. I will give you the hint. Cos of xy, when you will differentiate both sides with respect to x, derivative of cos of xy with respect to x will be minus sine of xy into derivative of xy. That is product rule. X dy by dx plus y into 1, that is y. And here you will have 1 plus dy by dx. Next, what you will do, you will multiply this inside the bracket. You will multiply this sine xy inside the bracket. So here you will get one term of dy by dx. Here also you have a term of dy by dx. Bring those two dy by dx together at one place and then solve for dy by dx. This also you can try on your own. I'll be now starting with, I'm going to solve this question for you, which is e raised to x minus y. This is ninth one. E raised to x minus y equals to x upon y. Now here what I notice is I have here power of e as e raised to x minus y. So since I have power expression here and on the other side I have numerator and denominator, I prefer to take log on both sides. I must say here that taking log is not mandatory here. It can be done even without taking log, but I will take log on both sides so as to make it simplified. Okay, you know, if you take log then the power become coefficient and the quotient become the difference. Here you have x upon y, so it will become log x minus log y. So here I write taking log on both sides before actually starting to differentiate. Taking log on both sides. And remember students, when you are taking log on both sides, it is to the base e, it is natural log. That is log to the base e. So I have log of e raised to x minus y. And remember, it is this way. E power e raised to x minus y. It is not this way. Remember, it is not this way. If it is this way, then this e will multiply. If it is this way, then this e will multiply x minus y, which is not the case. Okay, whenever given like this, it is always this way. And here you have log of x upon y. So the next step you get is, now see here, log of m raised to n. Log of m raised to n. This is n here. So this will become n log m. It will become n log m. So you have e raised to x minus y into log of e equals to log x minus log y. Now you know log e to the base e is 1. So you have e raised to x minus y equals to log of x minus log y. Okay. Now we can differentiate this. No need to take log again. It has been simplified. Okay. So I will now differentiate with respect to x. So differentiating with respect to x. Okay, why differentiate with respect to x? Because you can read the question. It is said find dy by dx. What's the question here? Okay, I'll write it. The question here is to find dy by dx. Find dy by dx. And what kind of function do we have? These all functions are known as implicit functions. They are all known as implicit functions. These all functions are implicit functions. Why? Because they are not in the form y equal to f of x. Instead, they are in the form f of xy equals to 0. You have x and y both together. So now when I differentiate with respect to x, here I'll get d by dx of e raised to x minus y, d by dx of e raised to x minus y. On the other side, I will get d by dx of log x minus log y. Okay, you know this step is redundant. You can skip this step. Okay, but you must write this at least. Okay, differentiating with respect to x, you must write. Now you know what kind of function is this. This is e raised to x minus y. So it is e raised to f of x function. So here the derivative will be e raised to f of x into derivative of f of x. That is e raised to x minus y into derivative of x minus y, which is 1 minus dy by dx, equals to, on the other side you have d by dx of log x minus d by dx of log y. So d by dx of log x is 1 upon x, and d by dx of log y is 1 upon y into d by dx of y. Now next step, you know what will happen. Since we see here 2 dy by dx, you will try getting them on one side. So before that, you will multiply this e raised to x minus y inside the bracket. So this will get you e raised to x minus y into 1, which is e raised to x minus y minus e raised to x minus y into dy by dx. And here you have 1 upon x minus 1 upon y dy by dx. You will take this 1 upon y dy by dx, you will shift it onto left hand side with this dy by dx term. Okay, and this one we will shift to RHS. So the next step now I get here is, I will get here therefore dy by dx. See here, this will be 1 upon y dy by dx minus e raised to x minus y dy by dx equals to 1 upon x minus e raised to x minus y. This step is again redundant. You could have skipped this step. Why? Because you take it there and take dy by dx common. So we could have written directly this step, the one which I'm writing now. It is 1 upon y minus e raised to x minus y. But students, please be very sure while transferring this, the terms here and there, because you have to be very minutely observant about the negative and the positive sign. Okay, it should happen to you on its own. You should not force yourself to do it. So here, and this side you have 1 upon x minus e raised to x minus y. Now what I will do is, I will take LCM on this and this side. So I get dy by dx equals to y, and here you have 1 minus y into e raised to x minus y. Okay, and here you have x is LCM, you get 1 minus x into e raised to x minus y. Now to get dy by dx, what you have in denominator will come in numerator, the numerator thing will come in denominator on the other side. So here we have now, the next step you have therefore dy by dx equals to, therefore dy by dx is equal to, you have x into 1 minus y into e raised to x minus y, x into 1 minus y into e raised to x minus y, and y into 1 minus x into e raised to x minus y. This is the final answer that we have. This is the final answer we have. This was an easy question, but I solved because we had to take log here. We had e raised to x minus y, so I solved this. So this is how it is. Okay, students, there is a possibility that if this question you get in any of the entrance exam, you know, there is a possibility that after you have solved this, the dy by dx, which should be this, you know, the options are A, B, C, D. You know, for that question, the options are A, B, C, D. And there is a possibility that after getting this dy by dx, okay, you will not see this answer anywhere. You may not see the answer anywhere. Okay, so in that case, you are actually surprised that why are you not getting the dy by dx? See, I tell you the reason. The reason is the answer that you got is a correct answer, but then the answer given in the option, the correct answer given in the option is the modified answer. Now, what do I mean by modified answer? See, the modified answers are obtained by substitution. The modified answers are obtained by substitution. Now here I would like to tell you, I would like to bring your attention to this part. See here, e raised to x minus y. Look at this, e raised to x minus y. This e raised to x minus y, we could substitute for e raised to x minus y from the given question itself. You can check here. See, you started differentiating at this very step. Where did you start differentiating? The differentiation started at this very step. Okay, so once you started differentiating, you have changed the function given. See, this function in this step is same as this. Now in this step it is still the same. You are just taking log on both sides. Whatever you are given, you took log on both sides here, so you got this step. But remember, this step and this step, they are same. Now here, you know, you are just simplifying. That is, you are applying the law of log. So this is also same as what you had. So till here, it is the same thing that they had given to you. Till here, it was the same thing that they had given to you. Okay, only after you started differentiating, the things are going to change now. That is, where you have log x, you will get 1 upon x. Where you have e raised to x minus y, you will get e raised to x minus y into derivative of x minus y. So till here, all the steps are same as what were given to us. Okay, now what I'm trying to tell you is, look at this step. From this step, what you see that e raised to x minus y is log x minus log y. So remember, students, before this step where you actually start differentiating, all the steps you have, this could be used in the answer. All these steps could be used in the answer. Okay, before this step where you actually start differentiating, here you have written derivative with respect to x, differentiating with respect to x. Before that, all the steps could be used there. So you know, here I have e raised to x minus y as log x minus log y, which is nothing but log of x by y. Log x minus log y is log of x upon y. So you know, the modified answer could here be, now I write the modified answer for you. The modified answer could here be as follows. The modified answer could here be as follows. It could be dy by dx equals to y into 1 minus x into log x by y upon x into 1 minus y into log of x by y. So there is a possibility that one of the answers, you know, one of the options which is correct, it is not in this form, but it is in this form. Okay, so you will have to be careful while attempting such questions in exam. We are going to take few more such questions in time to come. Let us start solving question number 10. And once again, we have to find dy by dx, and we are given an implicit function. Okay, see, we don't have in the form y equals to f of x. Instead, we have in the form y f of xy equal to 0. So what is first step, students? We will write differentiating with respect to x. So here I have d by dx of this thing equal to d by dx of this thing. So here d by dx of x is 1 plus d by dx of sine of x plus y, which is cos of x plus y into derivative of x plus y, which is 1 plus dy by dx. Okay, d by dx of sine x plus y is this, equals to d by dx of y, which is d by dx of y, that is dy by dx, minus d by dx of cos of x minus y. You know, derivative of cos x minus y will be minus sine x minus y into derivative of x minus y. So here you will get here minus of sine x minus y, that will make this plus. So sine of x minus y into derivative of x minus y, which is 1 minus dy by dx. Okay, so the next step, now what you notice is, see, this you will multiply inside the bracket. Okay, you are getting more than 1 dy by dx. Instead, here you are getting 3 dy by dx. See, there is one more here. Okay, so 1 here, 2 and 3. So you're going to get 3 terms of dy by dx. So you will try making that as a single term of dy by dx. So the next step you get is, so here you get 1 plus cos x plus y plus cos x plus y dy by dx. You get here cos x plus y into 1, and then plus cos x plus y into dy by dx. Okay, and see, equals to equals to dy by dx, and this sine x minus y will also multiply inside the bracket. So it is plus sine of x minus y minus sine of x minus y dy by dx. Now what you will do is all the terms of dy by dx you shift on the left hand side. Okay, the terms of the dy by dx you see are here. See, this is one term, two term, and the three term. Okay, so now this one which I'm writing here, this one, when I shift onto the left hand side, this will become positive, whereas this term will become negative. Okay, so see, the next step I get here is I will get the next step here as therefore dy by dx, therefore dy by dx I take common, and inside the bracket what I get cos of x plus y, cos of x plus y plus sine of x plus y. You know why plus sign? Because when this is shifted, this has become plus sign. Okay, it has turned to positive, and minus 1 equals to the rest all I shift on the right hand side. So what do I have? I have sine of x plus y. I have sine of x plus y minus cos of x plus y minus 1. See, I'm shifting these two terms onto the right hand side. So the next step I have is therefore dy by dx equals to sine of x plus y minus cos of x plus y minus 1, the whole divided by cos of x plus y, cos of x plus y plus sine of x plus y, cos of x plus y plus sine of x plus y minus 1. And see students, this is the final answer. This is your final answer that you have. You have this as the final answer, dy by dx. Okay, now see here, this is question number 4. Now in this question, this is all question of one simple type. Let's start with this question. What does it say? Very interesting questions these all are. It says show that dy by dx equals to y upon x in the following, where a and p are constants. So a, wherever you see in a question letter a, you will take it as a constant, and letter p is also a constant. Okay, so what we have to do here, we have to show that dy by dx, say for example, if we begin with this question, so here we are given x raised to 7 into y raised to 5 equals to x plus y raised to 12. Now this is an implicit function. What we have to do, we will differentiate, and finally what answer should we get? Dy by dx, we should get y upon x. Same way here. Look at the next question. The next question here is x raised to p into y raised to 4 equals to x plus y raised to p plus 4. If you observe this question here, this function, if you observe, you will notice that it is similar to the previous one. See, in the previous one, what happened, you know, that in the previous one, this power of x and y, they were numbers 7 and 5. Okay, 7 and 5, they are natural numbers, and on the other side you have 7 plus 5, 12. You see this? 7, x raised to 7 into y raised to 5 equals to x plus y raised to 12, which is 7 plus 5. Now look at the next one. Here also you have the product of x raised to p y raised to 4, x raised to p y raised to 4, and on the other side you have x plus y raised to sum of these two, p plus 4. See this? So the way you have the first question, the second is also the same. You know, so I will not solve both for you. I will solve only the second one. If I solve the second one, you can manage to solve the first one. Okay, I will solve the second one for you. And then similarly, you have several other questions. Remember students, all these questions, okay, these two are of one kind. These two are of one kind, one category. And then these all are into, they all fall into one category. Okay. But then if you see overall, this is one very simple type. You all have to understand how to solve this type. So what do I do now? I will start with the fourth second. I solve fourth second for you. Okay. So let us begin with this fourth second. The question is, see, we have to show dy by dx is y by x. So here I start writing fourth second. I write here fourth second given. What am I given? I'm given here, given x raised to p into y raised to 4 equals to x plus y raised to p plus 4. Okay, so what I notice is I have got here x raised to p, y raised to 4. I've got the product of these two functions. Okay, moreover, I see that I have also got the power. Okay, so if you remember, while differentiating the logarithmic function, you come across some functions where we said that if we have the product of several expressions, the power, then we will take log on both sides. Okay, why? Because taking log on both sides, the things will become much easier. The log of product is sum of logs. The log of power will become the coefficient of log. Okay, so as such, remember that taking log is not mandatory. It is not that if you don't take log, you cannot complete this solution. You can definitely complete, but then taking log, it will make it simple. So let us start taking log on both sides. So I write here taking log on both sides, taking log on both sides. Okay, now since I have already written this question, so let me turn this also into a black space. Okay, so here taking log on both sides, so I have log of x raised to p into y raised to 4 equals to log of x plus y raised to p plus 4. Now this is also a redundant step. You can always skip this. Okay, the next step will be you have log of, see this is this is m, this is n. So what you have log of m plus n. Okay, so you have log of x raised to p plus log of y raised to 4. Okay, what I did was I wrote this as y, it is actually 4. So here I have y raised to 4. So log of x raised to p plus log of y raised to 4 equals to, here you get p plus 4 into log of x plus y. So the next step you get p log x, plus 4 log y, p log x plus 4 log y equals to p plus 4, and you get log of x plus y. Now it is, see, now it has been uh, simplified to the best step. So you will now go for taking derivative. So you will write differentiating both sides with respect to x, differentiating with respect to x. And what is next? When you differentiate, you know it. Now what you can do is, so d by dx on left hand side and d by dx on right hand side. So here you have d by dx of p log x plus 4 log y, d by dx of p log x plus 4 log y. And on the other side, you have d by dx of p plus 4 into log of x plus y. You can always skip this step also. You can directly take log instead of writing this. So here I have, see, d by dx of p log x, which is p, derivative of log. P is a constant. So p is a constant, derivative of p. So p is out, and derivative of log x is 1 upon x plus 4. 4 is a constant, derivative of log y. D by dx of log y is 1 upon y into d by dx of y. Okay, and here you have p plus 4 being a constant. You will write it out, and d by dx of log of x plus y, which is 1 upon x plus y into derivative of x plus y, which is 1 plus dy by dx. Now what is next step? Once again, you see that you got more than 1 dy by dx, so you will try getting those dy by dx term on one side. So see here, I have p by x plus, see, this is 4 by y, this is 4 by y dy by dx. Okay, 4 by y dy by dx, and here see this p plus 4 into 1 upon x plus y, that is p plus 4 upon x plus y. So this p plus 4 over x plus y will multiply inside the bracket here. You see this bracket? So 1 plus dy by dx. So you get here p plus 4 upon x plus y into 1. It is this. And the next one you get p plus 4 upon x plus y into dy by dx. Okay, what I do is I take dy by dx term, all dy by dx term on the left hand side and this term on the right hand side. So see here, I get here 4 upon y, 4 upon y minus p plus 4 upon x plus y dy by dx. Okay, dy by dx. I have taken this term on the left and then taken dy by dx common. And why this negative sign? Because this when goes to the left, this turns negative. So, and on the right, I get p plus 4 upon x plus y minus 4 by, I'm sorry, minus p by x, minus p upon x. This goes to the right, minus p by x. So here now I get here a c. Inside I take the LCM. So y x plus y is the LCM. You get 4 times x plus y minus y times p plus 4, minus y times p plus 4. Okay. Then you have into dy by dx. And here what you have, here you have, once again, the LCM here is x plus y into x. You get here x times p plus 4, x times p plus 4 minus p times x plus y. Okay. So many a time, students, you will know that in derivative, you also require a great deal of simplification. You know, as such, derivative you take only in 2 to 3 steps, but after that, it's only that simplification of the steps that will be now required. See, derivative is over, but then you have to get dy by dx finally as y by x. So see, next step, what happens? Next step, it will be 4 times x plus y. Okay, let me multiply that inside. I'm working on the left hand side. I'm working on the left hand side. This side I'm working on. So here I get 4x. I get 4x plus 4y. 4x plus 4y minus py minus 4y. You understand this multiplies? Minus py minus 4y. And the denominator, see here. I have in the denominator 2 factors, y and x plus y, and here also in the denominator 2 factors, y, x and x plus y. So very simple, what will happen? This x plus y will cancel. Okay, so in the denominator on the left, I'm having only y. This is dy by dx into dy by dx. And see on the right what I'm having on the right side. Now I'm working for the right hand side. Okay, the right hand side I'll be writing here because I don't have enough space left. So here, see, I will get what I'll get here the numerator. I will get here px plus 4x minus px minus py upon x. Now you can check, students, what is going to happen. You know, on the left hand side in the numerator, see, this 4y cancels, and on the right hand side in the numerator, this px cancels. So what do you have? You have now the left hand side will look like it will be 4x minus py upon y dy by dx, and on the right hand side you have 4x minus py upon x. Okay, you can check in the numerator you have a factor. Here on the left hand side you have a factor, and what is it? It is 4x minus py, and here also you have 4x minus py. This cancels. If you have two factors on either sides of an equation, that will cancel. Okay, like suppose you have 4m equals to x into m, and you know that m is not 0. What will happen? This m cancels, so x is equal to 4. And if you don't understand this way, then you can think that this m will go in the denominator. So when it goes in the denominator, it cancels with m. So I have cancelled that common factor 4x minus py from both sides. Okay. So what am I what am I left with on the left hand side? I have 1 upon y dy by dx. So finally I get therefore dy by dx is equal to this y goes up there and I get y by x. And see, this is what they had demanded. This was the demand that they had. Okay, so hence proof, we got it. Whatever they had demanded, we showed it. I hope you have understood. You can watch this once again. Hello students, now see, after having done the second question, you all can solve the first one on your own. The first one you can easily solve on your own based on the similar steps. Okay, now I will come to question number 3, 4, 5. See, these all questions you will notice that I'm going to use the same technique. You will notice that in all these questions we will be using the same technique. Third, fourth, fifth, sixth, seventh, eighth, ninth, all. Now see, look at the third question. It is sec function on the left hand side. Okay, and then on the right hand side I have got equals to a square. What is a square? A square is a constant. Then in the next one it is tan inverse function. Okay, let me just enlarge this, let me just enlarge this, so that will make you understand much better. Okay, yeah, fine. See here, see, look at the third and fourth. Look at the third and fourth. What do you notice here is that in the third question you have sec function, on the left hand side, and then on the right hand side you have a constant a square. In the fourth one you have tan inverse function, on the right hand side you have some constant. So see, constant on the right, constant on the right. So similar thing you notice? Yes. Then on the left you have a function. So what if it's a trigo function here and it's a inverse function here? You have just, you see this, the similar type. Next, the most important thing that you will notice here is, look at the bracket, sec of, look at this bracket. You have x raised to 5 plus y raised to 5. And in the denominator, you have x raised to 5 minus y raised to 5. So see, what you have here, x raised to 5, you have x raised to 5 here. You have x raised to 5 plus y raised to 5. So down here, you have x raised to 5 minus y raised to 5. You see this? Now look at the similar thing happening here in the next question. You got here in the bracket 3x square, you have 3x square in the denominator. Now here you have 3x square minus 4y square. So down you have 3x square plus 4y square. What I want to tell you is, I want to bring to your notice that if you have a plus sign here, you have a negative sign here. See, opposite signs. If the numerator is positive, denominator is negative. If the numerator is negative, denominator is positive. You see the pattern? Look at the pattern. Okay, understand the pattern. That's why these all questions are going to follow one single idea. Moreover, what I want to tell you is that terms are same. See, x raised to 5, y raised to 5, x raised to 5, y raised to 5. 3x square, 4y square, 3x square, 4y square. I hope now it is clear to you all. That's why I'm saying that these all functions are going to be solved by one single idea. Okay, and similar thing you will notice even in the other questions, like question number 5, question number 6 also you will notice the similar thing. Okay, see question number 5. See, once again the similar thing you notice. See, on the right hand side, look at this, tan inverse of a. As I said, one, presence of a constant. See, presence of a constant, tan inverse of a. What if it is tan inverse of a? It is tan inverse of a. Now a being a constant, tan inverse of a is also a constant. You could have written anything without x or y, that would be constant. Just because you have tan inverse, that does not make that as a variable. It is still a constant. See here also you have a constant. So constant on the right hand side. Moreover, see, look at this cos inverse function and look at the terms. Similar pattern you see. What I made you all notice, the similar pattern you see here. And then here, see, you have a log function, the similar pattern you see here. Okay, same thing, similar thing you have as you had the question number, as you had in the third and fourth, you see the similar thing in fifth and sixth. Now let's go for seventh and eighth. See here, seventh and eighth. Look at this. On the right hand side, you have a constant a, and here what you have e raised to x plus x raised to 7 minus y raised to 7 upon x raised to 7 plus y raised to 7. You see this? You just have to take log on both sides. If you take log on both sides, the thing will look the way, see here, whatever I have, let me take log on both sides. So if I taking log on both sides, what will happen? I will have log of e raised to, and then this, okay, equals to log of a. And what do I have inside the bracket? Inside the bracket, I have x raised to 7 minus y raised to 7 upon x raised to 7 plus y raised to 7. Now, in next step, you know what will happen. It is in the form log of m raised to n. It's in the form log of m raised to n. So this will become n log m. It will become n log m. So you will get x raised to 7 minus y raised to 7 upon x raised to 7 plus y raised to 7 into log of e, into log of e equals to log of a. Now you know what is log of e. Log of e is 1. Log of e is 1. So the next step, what will happen? You will not have this. Log e is 1, so it's gone. Now what you have? What do you see here, students? You see the similar thing you have. One constant on the right you have, and see here what you have. You have x raised to 7 minus y raised to 7 upon x raised to 7 plus y raised to 7. See, you have the similar thing once again. Okay, and also the eighth question, you follow the same thing. Even in the eighth, you follow the same thing. Even in question number 8, you have the similar thing. Constant on one side and then one function, and look at the pattern here inside the bracket. All those problems we saw above, they had the same pattern. Okay, so this way we are going to deal with these all questions. So let us start solving them. So I'm starting with the solution of question number 3rd from the 4th. So 4th, 3rd. See, what am I given? I'm given here sec x raised to 5 plus y raised to 5 upon x raised to 5 minus y raised to 5 equals to a square, And what we have to prove, students? To prove that dy by dx is equal to prove that dy by dx is equal to y by x. We have to prove that dy by dx equals to y by x. Now see, students, just listen to, be very alert and very attentive for the few minutes ahead. You know, if I have to get dy by dx as y by x, one thing is sure, that I'll have to differentiate. Now, it is all very important. See, the most important step and understanding here is, the most important idea is that when to differentiate, which step, when to differentiate. That is the timing of differentiation, the timing. Now, by timing, I mean the step. At which step should we differentiate? That is what is most important thing you have to understand here. See, differentiation is must. Without derivative, you will not get dy by dx. But when should I? Should I differentiate immediately? Let's go for it. Just check. Should I differentiate it immediately? Suppose I differentiate with respect to x at this stage only. What will happen? See, you have this as sec f of x. You have sec f of x. So derivative of sec f of x will be, you know, d by dx of sec f of x is sec f of x tan f of x d by dx of f of x. So you will get sec of this bracket into tan of this bracket into d by dx of this bracket. You understand? You are now in a trouble. Into derivative of this bracket equals to 0. The right hand side derivative will be 0 because it's a square. But don't you think that something that you now have with you, it's gonna be put you in a big trouble? Why big trouble? Because having solved this, finally you want to end up with y by x. See, how many dy by dx you will get? You will have to apply division rule here. Here you will have to apply division rule. You understand? Division rule here. And then you also will have to manage all this. What will you do with sec? What will you do with sec? what you will do with tan, because in the answer you do not need tan and sec, you need only y by x. So if you differentiate it here, it's going to be, see, I'm not saying you cannot do it, but do you think for a problem which could be done in 5 minutes, you need to solve for half an hour? No, absolutely not. We are not going to do it this way, because I understand this is going to be a big trouble for me. Okay, this is going to be big trouble for me. So what will I do here? That is important. See, how do I go ahead? I will not differentiate immediately. What I will instead do is, see, I will write next step as, therefore, x raised to 5 plus y raised to 5 upon x raised to 5 minus y raised to 5 equals to sec inverse of a square. I'm applying the definition of inverse function. If sec x is y, we know that. What we know? We know that if sec x is y, then x equals to sec inverse of y. Got it? Yes. So I'm going to use this. So here I got x raised to 5 plus y raised to 5 upon x raised to 5 minus y raised to 5 equals to sec inverse of a square. Now, should I differentiate now? See, if you differentiate now, it is a little bit lighter than what it was earlier if you had differentiated. It has become a little bit easier. But remember, still if you go for derivative right now at this stage, you will have to apply u upon v rule. Okay? And see, the terms in numerator and denominator are to be handled. We will have to handle them very carefully, because we got two terms in numerator, two terms in denominator, and then taking dy by dx common and all that, it's going to take time. So we will not differentiate here also. What I will do, students, you remember in lower grades, when you learned ratio and proportion, in that topic you had been taught something like componendo, dividendo for ratios. When you have two ratios equal to each other, suppose I have A upon B equal to C upon D. If I have two ratios which are equal to each other, I have A upon B equal to C upon D, then by applying componendo and dividendo here, by applying this idea here, what I will get is, I will get A plus B upon A minus B equals to C plus D upon C minus D. What does it mean? It means if A upon B equal to C upon D, it means if A upon B equal to C upon D, if this is true, if this ratio is equal to this ratio, if this is true, then this is also true. Then this is also true. This is also true. And this technique is known as componendo dividendo, applying componendo dividendo. In this, what we do? Very simple. See what we do. In this, we add the denominator to the numerator, write it in numerator. Then we subtract the denominator from the numerator, write in the denominator. So see, A plus B upon A minus B. And the same thing we do here. We add the denominator in numerator, write in numerator, subtract the denominator from numerator and write in denominator. Okay. So A plus B upon A minus B equals to C plus D upon C minus D. This I'm going to use here. And when I do this, see what I will end up with. So here I write, see, sec inverse A square, I can always treat upon 1. I can always say it is upon 1. Yes, dividing by 1, you get the same thing. So you will write divide by 1. Now what I will write here, using componendo. See what we have. We have A upon B. I treat this as A. So this is A. upon B equals to C upon D. Okay. So now what I write using componendo and dividendo. Componendo, componendo, dividendo. We get, see, we add the denominator in numerator and write in numerator. So x raised to 5 plus y raised to 5 plus x raised to 5 minus y raised to 5. You are adding, so the sign will not change. Now you will subtract the denominator from numerator. So you will get x raised to 5 plus y raised to 5. Now you're subtracting, so the sign will change. Upon x raised to minus x raised to 5 plus y raised to 5, the sign has changed. You do the same on the right. So you got sec inverse a square plus 1 and sec inverse a square minus 1. And now you write the next step. See what will happen in the next step. If you haven't known this, if you have not known this earlier, please, you will make a note of this also. Componendo, dividendo. Please make a note of this also in your notebook. See, now here what happens is this y raised to 5 cancels and down here x raised to 5 cancels. So you have now therefore, see, you have therefore 2 times x raised to 5 upon 2 times y raised to 5 equals to look at this, what you have this as everything is a constant. See, sec inverse a square is a constant plus 1 constant divided by sec inverse a square minus 1 constant. Constant upon constant is a constant. Okay, so here I write k, and here I write where k is a constant equal to RHS of equation RHS of equation 1. See, it is equal to RHS of equation 1. Now what, this 2 and 2 also cancels, this 2 and 2 cancels. So the next step I have is therefore x raised to, see, x raised to 5 upon y raised to 5. So x upon y the whole raised to 5 equals to k. Now what I will do, now I will take the fifth root on both sides, raising index by fifth root. You understand fifth root means on both sides I'm taking the fifth root, that is raising index by 1 by 5 on both sides. So here what you will have, this and this cancels. You got it? So I'm taking the fifth root on both sides. Okay, I write here raising index or raising power, whatever, raising power on both sides by 1 upon 5. Okay, so you will get, see, this whole thing raised to 1 upon 5, you know what it will become? It will become simply x upon y, and here you have k raised to 1 upon 5. And now I differentiate, students. I write here differentiating with respect to x. See, what you had at one stage, you had this, and now what you have this. So you can just imagine how you have simplified it. Up to a great extent, you have simplified this. Okay, so here now I write differentiating both sides with respect to x. I will get therefore d by dx of x upon y equals to d by dx of this, which is 0. D by dx of a constant is 0 there. So the next step what you have is, see, now you write therefore now here apply division rule. You have y derivative of x, which is 1, minus y into derivative of x, which is 1, minus x into derivative of y, which is dy by dx, okay, upon y square equals to 0. Now this y square multiplies here, so you have y minus x dy by dx equals to 0. So you have y equals to, now this goes on the left, y equals to x into dy by dx, and this gives you Therefore, dy by dx equals to y by x, and hence proved it. You have got the answer which they wanted you to get. I hope you all have followed this. In case if you want a repetition, you can again watch the whole thing. So students, as I solved this problem for you, okay, you can do this one on your own. You can do it on your own. What you will do, the next step, the very next step, you will write given, then the very next step you will take tan inverse here. So it will become tan of a square. See, here you have inverse. So when it goes on the other side, it will become tan of a square. If you had simply tan, then you would have made it tan inverse. Since it is tan inverse, you will make it tan of a square. Okay, and after that, you understand everything will be the same. You will go for componendo, dividendo, and all that. You can easily manage it. Just do not worry. It is going to be simple. Now here, look at the, so this is for you. This is for you. This is a homework problem. This one is for you. Look at this. Here in the fifth one, you have cos inverse of 7x raised to 4 plus 5y raised to 4 upon 7x raised to 4 minus 5y raised to 4 equals to tan inverse of a. Just do not bother about this, tan inverse and all that. It's a constant. Treat this just as a constant. So in the very next step, what you will do, this is cos inverse on the left hand side. The next step you will write and it will be cos of this. This will go here. So in the very next step, you will get 7x raised to 4 plus 5y raised to 4 upon 7x raised to 4 minus 5y raised to 4 equals to cos of tan inverse of a. Just do not bother. The next step is, see, it is still a constant. This whole thing a constant. You will take upon 1. Then what? Go for componendo dividendo and solve the problem. Then see, after that, so this is also a practice problem for you. You will do this. And also you will do the eighth one. Okay, you will do the eighth one also. So the only problem that you are now left with is these two, and I will solve one of these, the other you can easily solve. Okay, so for now I end this video. I end this lecture. We will see this sixth and seventh. We will see in the next lecture. Thank you.